Okay, so today let's start a new chapter, that is our maximum and minimum of a function. Now, do you have any idea what do you mean by maximum value of a function? Tell me about that. Do you have any idea about this? What do you mean by maximum value? No, sir. Okay, you don't know. Okay, so let's just give me 1 second. Let me open the book. Okay, look. Now we are going to define what is the maximum value. Maximum value of a function in a given intervals. What is the maximum value of a function in a given intervals? Okay, let us consider a function f of x, any function f of x equal to 0, and let's draw the graph of the function. Okay, we're taking that the graph is like that. Suppose the graph of f of x is like that. Okay. Now, if I consider, suppose this is our a point and this is our b point, means the domain of the function is from the point A to the point B. Now, we are consider a very small part of its domains. Okay. Suppose we are considering this part. This is a point and this point is b point. Okay. A very small part of its domain, means we are considering the open intervals a and this is suppose b. Suppose this is c point, this point is c point at x equal to c. So, look, at in this domain each and every point we can calculate the value of the function. Suppose if I consider any point x1, so at x equal to x1, what is the value of the function? F of x1. Similarly, at x equal to x2, what is the value of the function? X equal to x2. Similarly, at each and every point of these subintervals, we can calculate the value of the function. Now, out of this, sir, please, Srijita, sir, please call Srijita individually. Okay, Srijita is not joined here. Yeah. Okay, I am calling her. Just wait a second. Okay, now let's continue. Now, on this subinterval, for each and every point of x, we have a corresponding value of y. Okay, welcome. We have a corresponding value of y. Now, we'll just concern for those values of y or those value of f(x) which is maximum from the rest of the value. Okay, that value is called the maximum value of this interval. Okay, means suppose this point is c. At this point, f of c is greater than all value other than this interval. Then you are on the group, but you can't join. Just give me. Okay. Now look, the point at x equal to c is said to have a maximum point if the value of f of c is greater than the other value of f of x in this interval. So, this is called a local maximum point. This is called a local maximum point. Okay. And what is the local minimum point? Suppose at this point, suppose at x equal to c1. So, value of f of c1 is less than the other value of f of x in this interval, then we say that the function has a local minimum point in these subintervals. Okay, so this is the actually local maximum value and the local minimum value. Okay, now I am telling you the definition of local maximum value and local minimum value of a function. Okay, so I am drawing two curves. This is first curve. Okay, suppose this is first curve. Now we are taking 2 points here. One is P point, one is Q point, and one is R point. Clear? Now look, if I draw a tangent at the point P, if I draw a tangent at the point P and we consider that this tangent make an angle, suppose alpha 1 with the positive direction of x axis. Okay, and the equation of curve is y equal to f of x. So what does f dot x mean? Can you tell me what does f dot x mean? F dot x means derivative, but it has a geometrical interpretations. Can you tell me what is the geometrical interpretation of f dot x? What is the geometrical interpretations of f dot x? Quickly. Okay, I am giving the answer. So f dot x means the slope of the tangent, means slope of the tangent. F dot x means the slope of the tangent. Now at P point the slope of the tangent will be tan alpha 1, because the tangent make an angle alpha 1 with the positive direction of x axis. So slope of the line will be tan alpha 1. Okay. Now from the slope of the tangents geometrical, yes, yeah, very good. Now from you can see the graph. Now look, it has a two part. One is left hand side of this line and one is the right hand side of this line. Now look, when in the left hand side the curve is gradually increasing, and on the right hand side the curve is gradually decreasing. Okay. Now when a curve is gradually increasing, so can you tell me what will be the range of the slope, means inclination of the tangent at any point? What is the value of this alpha, maximum value and minimum value? Now look, maximum value and the minimum value of alpha 1 will be 0 to pi by 2, means this angle lie on the first quadrant. This angle alpha 1 must lie on the first quadrant, and we know that in the first quadrant the value of tan alpha is positive, means greater than 0. So if a function is increasing function, we know that f dot x is greater than 0. We have learned it in our previous classes, that when f dot x is greater than 0 means the function is increasing, and similarly if the function is increasing, in that case f dot x is greater than 0. Now if I consider another point, suppose r here, and if we draw a tangent, let this tangent make an angle alpha 2 with the positive direction of x axis. So what will be the value of alpha here, means range of alpha here? If I draw, so if this angle is alpha 2, that makes the tangent with the positive direction of x axis. So in that case the range of alpha 2 will be pi by 2 to pi. In this intervals alpha 2 will lie, means it will lie on the second quadrant, and we know that the value of the tan alpha, yes, it's pi by 2 to pi, very good. Now we know that the value of tan alpha in second quadrant is negative. Okay. So in that case f dot x is negative and here it is positive. So, look, the graph is initially gradually increasing and certainly it's gradually fall down. So, there must be a point where the value of f of dot x will be 0. Here the value of f dot x is positive, here the negative. So, there must be a point where the f dot x will be 0, isn't it? This point is called the critical point or the turning point of the curve. I think you are familiar with the word critical point. So, this point is called critical points or turning points of the curve, because at this point the curve change its nature. The curve is turning from positive to negative. Okay. Okay. So, this is the increasing function. Okay. Now, and maximum value or minimum value will occur at this critical point. The maximum value or minimum value will occur at this critical point. Suppose this point is C. Okay. Now, if I consider any point, suppose C minus H, and here another point is C plus H, where H is very small number. H is tends to 0. It's a very small number. H. Okay, sir. I am discussing the. Yes, this class is being recorded. You will get in our YouTube channels. Okay, I am repeating it against here. Now look here. Look here. Look at the changing of the nature of the curve. Here, the curve f dot x is greater than 0, and in this portion f dot x is less than 0, and the curve is actually the curve is a continuous curve. So, between these 2 points there must be a value of x, must be a point for which f dot x will be equal to 0. Okay, because it is an increasing function, f dot x is greater than 0, and here f dot x is gradually decreasing less than 0. So, there must be a point, where f dot x is greater than equal to 0. That means the tangent at that point must be parallel to x axis, and the point where the tangent is parallel to x axis is called a critical point or turning points of the curve. Okay. Now, have you understood this, Shreya? The critical point and the turning point? Critical point or the turning points? Yes. Okay. Now, we will calculate, means we will derive a formula how to find the maximum and minimum points. Okay. So, in the neighborhood of C, we are taking 2 points. One is C minus H and one is C plus H. Okay. Now, tell me what is the value of f of C minus H is greater than or less than f of C. What will be the sign we will use between these 2 terms? Which is the greatest number, f of C or f of C minus H? Obviously f of C. So, we can say that f of C minus H is less than f of C. Also if I draw the ordinate at C plus H, so this is actually f of C plus H and this is f of C. Now, which is the greater number between f of C and f of C plus H? So, from the diagram we can say that f of C is greater than f of C plus H. Okay, f of C is greater than f of C plus H, means in this sub interval, in this neighborhood of C, the maximum value of the function occur at x equal to C. In that case, the point C is said to be a local maximum point, means f of C is maximum, f of C has maximum value rather than the other point on this sub interval. So, the function we called it is a maximum value. Okay, so now I am writing the definition. So a function f of x, is said to be attain its maximum value at x equal to c if f of c is greater than f of x for all x belongs to interval except at x equal to c. Means the value of the function at x equal to c is greater than the value of f of x in the remaining point on the interval. Similarly, the function f of x is said to be attain its minimum value at x equal to d if f of d is less than f of x for all x belongs to I. Okay, I am explaining this one first. Suppose there is a decreasing function. Okay, so maximum value will be minimum value will be occur at x equal to d. Okay, if I take any points here x, so this is f of x and this is f of d. Now tell me which is the greatest value between f of x and f of d. So obviously we can see that f of x is larger than f of d. That means f of d is less than f of x. And if I consider f of x here, so here also f of x is larger than f of d. Means if x equal to d is said to be minimum point of the function if f of d has the lowest value among all f of x. Okay, so this is the definition of maximum value at the minimum value. Now tell me, have you understood what is the maximum value or what is the minimum value? Yes. Okay, now we'll check how to find the derivative of how to find the local maximum value and the minimum value of a function. So we have two procedure. One is using the first derivative test and second is using the second derivative test. So I am doing the first derivative test first. First derivative test. Okay, I am writing the step one by one. So first there will be a function f of x. Step 2, first differentiate this function and find f dot x. Step 3, find the critical point. And how to find the critical point? We know that if we equate f dot x with 0, we have some critical points. Let the critical points are C1 and C2. We are considering two critical points. Okay, C1 and C2. Now look, just we have drawn a graph here like this. Okay, so if f dot x is greater than 0 here and f dot x is less than 0 in this case, it means it is positive and on the other side it is negative, then there exists a maximum point at x equal to c, means where c is the critical point of the function at this interval. Means when the nature of f dot x changing from positive to negative, we have a maximum point there. And if the nature of the f dot x is changing negative to positive, in that case we have a local minimum points. Okay, so what step 3 is, let this is the interval. If any interval is given, so consider that interval, otherwise we will consider the whole real number from minus infinity to plus infinity. Okay, now put the critical point. Let C1 is a critical point and C2 is the another critical points. Now calculate the nature of the f dot x in this subinterval minus infinity to C1. Okay, let us consider it is positive. It may be negative, it's depending on your question, but we are considered this is positive and this is negative sign, and abrotex, nature of abrotex in the interval C2 to infinity is again positive. Now look here, the nature of the abrotex is changing from positive to negative. So why we can conclude? We can conclude that the function has a maximum value at this interval, because we know that when nature of abrotex is changing from positive to negative, so we call that there exists a maximum value at this critical point C1. Also look here, the sign of the abrotex is changing from negative to positive, and we know that when the nature of abrotex is changed from negative to positive, we have a local minimum point at the critical point C2, isn't it? So we can say that this is the first this point has a local maximum point, and at this point we have local minimum point. And if the question is like that, find the local maximum value or the local minimum value, so how we can find? We know that we have a local maximum value at x equal to C1. So to find the local maximum value, we have to put x equal to C1 in your given function. So f of C1 will give you the local maximum value. It give you local maximum value, and f of C2 will gives you local minimum value. Okay, so this is the step through which we can check whether a function has a local maximum value or local minimum value. So do you understood the step? Yes, I am giving you a question. Okay, so let's check. Find the local maximum value and local minimum value of the function. So let us consider f of x is equal to x cube minus 6x square plus 9x plus 5. One curve is given here. We have to find the local maximum point and the local minimum point. So what we have to do? First we have to differentiate it. So do the derivative. Abrotex will be 3x square minus 12x plus 9, and derivative of 5 is 0. Now calculate the critical point. We know that the critical point can be calculated by equating abrotex with 0. That implies, now put the value of abrotex, that is 3x square minus 12x plus 9 is equal to 0. Now if I take 3 common from here, so it will be x square minus 4x plus 3 is equal to 0. Now do the factorization and find the critical points. So the critical point we have x minus 3 into x minus 1 is equal to 0. So for the critical point we will equate x minus 3 with 0 and x minus 1 with 0. From here we have x equal to 3, and from here we have x equal to 1. So now we have calculated the critical point as 1 and 3. Okay. Now look at the domain of the function. No specified interval is given, so we will consider the domain of the function is minus infinity to plus infinity. Now by this critical point, the total domain is now divided into 3 parts, at x equal to 1 and x equal to 3. Okay. Now we will check what is the nature of the abrotex in this interval minus infinity to plus 1. So in minus infinity to plus 1, what is the nature of abrotex? Okay, in the previous class when we are doing the maximum and minimum increasing and decreasing functions, we have done this type of problem. So in that case we have to take we take points lying in this interval. For example, if I take minus 5 here, okay, so it will be minus 5 into minus 3, that is minus 8, and minus 5 into minus 1, that is minus 6. So 8 into 6, so the result will be negative. So abrotex is negative, means this is a less than 0. Okay, this is less than 0, sorry, positive. This is negative, this is also negative. So, the result will be positive. Shreya, the result will be positive, not negative. And in this intervals, when x lie between 1 to 3, okay, so let us consider the point is 2. So, put x equal to 2 here. So, 2 minus 3, that is minus 1, and 2 minus 1, that is 1. So, minus into plus. So, in that case f dot x will be negative. And when x lie on 3 to infinity, okay, in that case the value of f dot x will be positive. Okay. Now, look at the diagram. Now, here the nature of the f dot x is changing from positive to negative. So, what we can say that? We can say that the function has a maximum value, maximum value at x equal to 1. The function has a maximum value at x equal to 1. And here the value of the function or the nature of the function is changing from negative to positive. So, we can conclude that it has a minimum value at x equal to 3. So, we have calculated where the function has a maximum value and the minimum value. Now, if the question is that find the maximum value or the minimum value. So, what we will do? So, we will put x equal to 1 in the given function. So, put x equal to 1. So, the local maximum value will be f of 1. Now, put x equal to 1 in this expression, and the minimum, yes, 9, very good, and local minimum value will be f of 3, that is equal to 5. So, this is the maximum value and this is the minimum value, actually local maximum and local minimum, or you can say maximum and minimum in this throughout of its domains. Okay. So, this way we can calculate the maximum value and minimum value of a function. Okay. So, today up to this much. Next day we'll learn how to find the maximum and minimum value of a function by using second order derivative. Okay. So, up to my next class. Bye bye. Thank you. Bye.